All right, so we've all played around with AI that can chat with us or, write a halfway decent email. But what if that's just the tip of the iceberg? Today, we are diving into a huge leap forward. We're talking about AI that doesn't just answer our questions, but actually takes action, builds its own teams, and, get this, evolves all by itself to get better at its job. This is where AI gets really, really interesting.
And that's the big question, isn't it? Can AI move beyond just waiting for us to type in a command? Can it actually go out and chase a goal, work with other AIs, and most importantly, learn from its own mistakes and successes? And I'll tell you, this isn't sci-fi anymore. This is the stuff that's being built right now.
Okay, so to really wrap our heads around this jump, we first have to get clear on the difference between the AI we're used to and this new kind that's emerging. We're talking about a move beyond the soloist, that single brilliant AI, to something way more dynamic.
Think of it like this. A standard large language model, an LLM, is like a genius researcher locked in a library. It has access to pretty much all the information in the world, but it can't actually do anything with it. It's stuck in the room. An AI agent, though, that's a completely different animal. It's like a proactive freelancer. You give it a goal, and it doesn't just spit back an answer. It goes out, uses tools like Google Search or code interpreters, and actually tries to get the job done. So, what's the secret sauce here? What gives an agent this incredible ability to take action? Well, it all comes down to a few core components that work together. Kind of like an engine for reasoning and action. Let's pop the hood and take a look. So this engine really has four main parts. First up is perception. That's how it takes in information from the world. Then there's planning, which is crucial. It lets the agent break down a massive goal into small, manageable steps. Of course, it also has memory, so it doesn't just forget everything it does, it learns. And finally, and this is a big one, is tool use. This gives it hands to interact with the digital world, to search the web, run code, and actually do things. These four pieces are what turn a passive model into an active agent. A single agent is powerful, for sure, but when you're talking about really complex, messy, real-world problems, well, one freelancer, no matter how talented, is eventually going to hit a wall. And this is where we see the next big evolution, building a whole team of them. Yeah, the real world is complicated, right? A single agent trying to be an expert in everything, from coding to market research to talking to users, it's just going to get overwhelmed. It's like trying to get one person to design and build an entire skyscraper. They just don't have the specialized skills for such a huge challenge. And that brings us to what are called multi-agent systems, or MAS. This is where you don't just have one agent. You build a team of specialists. You could have a researcher agent that just scours the internet, a coder agent that writes and debugs programs, and maybe a project manager agent that keeps them all on track. They each have their own job, they share what they find, and they work together. And suddenly, they can tackle problems that would be absolutely impossible for a single agent. Okay, but here's the catch. Even these super advanced AI teams have a hidden weakness. On the surface, they seem incredibly dynamic, but underneath, their structure, their whole playbook, is often surprisingly rigid because it was designed by a human. This quote from the research really just hits the nail on the head. A human engineer, a person, has to sit down and meticulously decide which agents are on the team, exactly how they're allowed to talk to each other, and which specific tools they can use. The entire system is pre-programmed, or, as they say here, handcrafted. And here's why that's a massive problem. A static, handcrafted system is fragile. What happens when a competitor releases a new product, or a new, better software library comes out? The AI team can't adapt on its own. A human has to go back in and manually rewire the whole thing. It just can't keep up with a world that's constantly changing. And this is the moment we see the next paradigm shift. The solution to this whole static workflow problem is to build AI systems that aren't just programmed to follow a plan, but are actually programmed to learn how to make a better plan, all by themselves. So what exactly are self-evolving AI agents? Well, they are systems designed to optimize themselves. By actually doing things in their environment and getting feedback, they automatically adapt everything, their instructions, their team structure, the tools they use, all of it to fit a constantly changing world. So, in other words, they don't just follow the playbook, they're constantly rewriting. So how on earth does this self-improvement actually work? Well, it's based on this really elegant closed feedback loop. You see, the agent team tries to do a task out in the wild. The environment then gives it feedback. Did it work? How fast was it? Then a special optimizer component looks at that feedback and makes changes to the system. Maybe it tweaks an agent's instructions or totally changes who talks to who. Then the cycle starts all over again, with the team getting a little bit smarter, a little bit better, every single time.
And when we say they change the system, what can they actually change? The answer is pretty much everything. They can evolve their own prompts, literally rewriting their own job descriptions to be more effective. They can change the topology, which is the team's entire structure and communication flow. They can get better at using their tools or even create brand new ones from scratch. And they can improve their memory, learning how to find the right information faster. It is a complete, top-to-bottom automated optimization process. It's incredible.
So this isn't just a cool idea from a research paper. This is a genuinely new paradigm. Self-evolving agent systems are already being used to tackle some ridiculously complex problems. And they are pushing the absolute boundaries of what we thought AI could do.
I mean, just take a look at some of these applications. In science, these systems can act like an AI co-scientist, coming up with their own ideas and then testing them. For software, they can form a whole development team to build and debug complex applications. They're being used to simulate conversations between doctors and patients to improve diagnostics, and even to model courtroom arguments to help with legal reasoning. This is where things get truly mind-blowing.
And all of this leads to a pretty profound question. When an AI can come up with its own hypothesis, design its own experiment, and improve its own methods over time, is it still just a tool? Or is it becoming a genuine partner in the process of discovery? We might just be looking at the very beginning of autonomous science itself, and that future is unfolding as we speak. Thanks for digging into this with me.